Ever looked up at the night sky and seen the second brightest object after the moon? That's Venus, often called Earth's twin, but is it really? Let's dive into the scorching secrets of the hottest planet in our solar system. Venus and Earth are almost the same size and mass, and they're made of similar rocky material. They're also neighbors. Because of these similarities, scientists once thought Venus might be a lush, tropical paradise, maybe even with life. Boy, were they wrong. So why isn't Venus Earth's twin? It all comes down to the atmosphere. Venus has a thick, toxic atmosphere that's about 90 times denser than Earth's. Imagine being almost a kilometer deep in the ocean. That's the kind of pressure you feel on the surface of Venus, and this atmosphere is almost entirely carbon dioxide, a potent greenhouse gas. Now, you've probably heard about the greenhouse effect here on Earth. It's when gases in the atmosphere trap heat from the sun. On Venus, this process has gone completely wild. Sunlight passes through the clouds, heats up the planet's surface, and then gets trapped by that super dense carbon dioxide blanket. It can't escape back into space. This runaway greenhouse effect has turned Venus into a planetary oven. The average temperature on its surface is a staggering 465 degrees Celsius. That's hot enough to melt lead. To put that in perspective, Mercury is the closest planet to the Sun, but it's not the hottest. Venus is. Mercury has almost no atmosphere to trap heat, so its dark side gets incredibly cold. Venus, on the other hand, stays blazing hot all over all the time. The clouds on Venus aren't made of water like on Earth. They're made of sulfuric acid. That's right, it literally rains acid there. These clouds are so thick and reflective that they bounce most of the sunlight back into space, which is why Venus appears so bright to us. But the small amount of sunlight that does get through is enough to fuel the runaway greenhouse effect. Landing on Venus is incredibly difficult. The extreme heat and crushing pressure mean that spacecraft don't last very long. The Soviet Union's Venera probes were the first to successfully land and send back images, but they only survived for a couple of hours at most before being destroyed. Those first images showed a barren, rocky, and dimly lit landscape under an orange sky. So, what happened? Why did Venus end up so different from Earth? Scientists believe that billions of years ago, Venus might have had liquid water oceans, just like Earth, but being closer to the Sun, the water evaporated faster. Water vapor is also a greenhouse gas, which raised the temperature even more. This created a feedback loop. More heat led to more evaporation, which led to more heat. Eventually, the water vapor in the upper atmosphere was broken apart by the sun's ultraviolet radiation, and the hydrogen atoms escaped into space. Without water, carbon dioxide from volcanic eruptions built up in the atmosphere, creating the thick, hot blanket we see today. The planet's geology also played a part. Venus doesn't have plate tectonics like Earth, which helps recycle carbon back into the planet's interior. Studying Venus is crucial. It's a stark warning of what can happen when the greenhouse effect runs out of control. It helps us understand the delicate balance that makes a planet habitable and highlights the importance of protecting our own atmosphere here on Earth. So, the next time you see that brilliant evening star or morning star in the sky, remember you're not looking at a tranquil paradise. You're looking at a hellish world of crushing pressure and unimaginable heat, a fascinating but terrifying reminder of how planetary fates can diverge. It's a cautionary tale written across our solar system. Thanks for watching. If you enjoyed this journey to our twisted sister planet, don't forget to subscribe, and hit that notification bell for more deep dives into the cosmos. See you next time.